So now can see the screen? On the mic, please answer.
Can see.
Okay, so now we start with the tutorial 3.2 Kepler law. Okay, let's see the question 1. Okay, question 1. Okay, we see the question first. We go to explanation. Okay, first one, they say stationary satellite. They orbit in 24 hours. So this one, first one, they provide the time. Time taken is 24 hours, but we never using hour. We need to using a second. So therefore, the satellite always at the same point on the Earth's surface. Okay, Earth's surface. So Earth's surface, we no need to count the extra h. They're just normal radius. Okay, now you need to calculate the radius of the satellite orbit. Okay, the satellite is orbit surface of the Earth. So from here, you need to find r. Okay, how many? Then the question provide the time only. Okay, so refer here. We got some info. They're from at the top. So normally we need to use is a mass lah, the mass of the Earth. Okay. Then after that, the radius is cannot copy here. If you copy here, then we don't need to do calculation already. So from here, another one we need to use is this one. Okay, the constant gravitation. Okay, so now we go to apply the formula. Okay, you see which one formula they got R and also they got time taken. So from here, I find it just got this one only. Okay, we need to find the R, then the question they provide the T. So now we go to make sure which one unit is, which one physical quantity we cannot get the answer. If cannot get, then we cannot use the formula. Okay, first one, mass of the Earth. Okay, we refer the just now they got provided. G, we also know there's a constant number. 4 pi square. Okay, 4 pi square is okay. Just press calculator. So now the time taken period they provided, there's a 24 hours. You convert become second. Then you need to find is a R. So we're using this formula to find the radius. Okay, so from here, we just apply the formula. Mass for the Earth equal 4 pi squared R cubed. Then after that, GT squared. Okay, so from here, we need to move the R cubed alone. So ME must be multiplied with the G and T squared, then over 4 pi squared. So you find the answer for R cubed, there's a 7.53. Got so many decimal points, so I just take 2 only. Okay, 22. Okay, but now the question they want radius, they don't want cube. So you need to cube root. Okay, so it becomes 4.22 times 10 power of 7 meter. Okay, the first question I give you the answer. The rest you need to give me answer. So the first one, any question you want to ask? How many here already finished? Then you get the correct answer. Then just on your mic, tell me yes. That's all. Okay, if this one no problem, I want to go to the second one. Question number 2. Okay, question number 2. A satellite, again, sent a near surface of the Earth with the speed and is orbiting the Earth. Now you need to calculate the satellite speed and period, one complete round resolve around the Earth. Okay, surface. First one we know surface. When they're talking about surface, understood R is a radius of Earth. Okay, now they want you to find the speed. Okay, another one, they want to period. Okay, so from here, we need to using the information from this side. Okay, from this side, okay, means mass of the Earth we need to use. Okay, G we need to use. Okay, so the radius, is it we need to use or not? I think need to use because the question never provided. Okay, so from here, we need to use the radius of the Earth also to do the calculation. Okay, so from here, they want to find V. So we're going to see which one formula got V. Okay, this one. Okay, this one formula got V. Then we just apply, find what is the speed. Okay, find all the speed. Okay, first one, the speed of the satellite. V equal, okay, this one is a number 1. Okay, V equals square root, capital G, bigger M over the R. So we just apply, so we find it, the V is a 7.0908 times 10 power of 3 ms negative 1. Okay, so this one is the information. If the question never provide this part, constant value, if they never provide, they must provide inside the question. So this one question never write anything, means you need to refer this part. Okay, if you find the V is okay, now we need to find is a period. So normally the speed must related with the period. Okay, now we're going to see which one got period. Okay, got period, sure is this one. Okay, if you don't want to using this one, is okay. Remember one of the centripetal force, we learned about the speed. There's a V equal displacement over time. Okay, now the displacement is a circle. So we take there's a 2 pi r over the period. Okay, over the period. So from here, we need to find what is the t. So you take just now the velocity, 7.908 times 10 power of 3. Okay, then equal, then 2 pi. Okay, r. Put your r in, the r from here. 6.37 times 10 power of 6. Okay, then over t. Then finally, you need to move the t, go another side to find the answer for t. So finally, your period here, 5.061 times 10 power of 3 seconds. If you put 5.06, is okay already. Minimum 2 decimal point. So this one is your answer. First for speed, second one is time. Okay, any question? Just got question, it's on your mind, then you just ask. Then we stop, then we discuss. If I wait you around 5 seconds, nobody go to answer, I mean, I pass already lah, I go to another question. Okay, nobody answer. Okay, nobody answer, nobody want to ask, then we continue with the question number 3. Okay, satellite again at a distance r from the center of the Earth. So this one means the satellite not on the surface. They got distance r from the center of the Earth. So this one is Earth, this one is the radius, they got r. Satellite is here. Okay, by using the universal gravitational law, calculate the satellite speed and period. Again, speed and period. Okay, after that, resolving around the Earth in terms. Okay, the answer they don't want got value. They want the answer in M, R, and G. That means your answer don't have magnitude. They just got M, R, and G. So the first one, we find speed. Okay, if speed, we just apply lah. You want the formula MRG. So V equal square root GM over R. That's all. This one is the first one. Okay, number 2, period. Okay, how to find the period? Period we remember just now we show already. V equal 2 pi R over T. We write capital T. Okay, period. So from here we know T is here. But now I don't want got unit V. I don't want got V. I just want the answer in MRG. Okay, so just now the V equal, okay, G, M, and also R. Now T also same. I want T equal something, but G, M, and R only. Don't want got V. So from here, this one whole thing must put in here. So we do the ganti, this one just put in. So you just put 2 pi R over T equal square root G, M, R. Okay, so now you just do your calculation. Square root you put here. So 4 pi square r square over t square equal em over r. Okay, after that, GMT square equal 4 pi square r cube. Okay, finally, I want t only. So 4 pi square r cube over g m whole go to square root. So this one is my answer. Okay, this one is my answer. So I proved already the first one. B equal square root gm over r. Second one, t equal 4 pi square r cube over gm. So from here, we don't have other physical quantity. We just got m, we just got r, and we just got g. So this one question is in terms. That means they don't want the answer with unit. Okay, they don't want the answer with value. They just want physical quantities. Okay, number 3. Question. Okay, no. There we go, number 4. Okay, number 4, I just explained. Then you give me answer. Okay, number 4, you're going to see what is that. Satellite 1. Okay, we got satellite 1. First orbit. Then after that, the period T1 is 24. So we just write here, T1, 24 hours. Okay, or you can say 86400 seconds. Okay, they count for you. If the Earth distant to the satellite 1, okay? If this one, okay, so this one is a distance. So it means the distance never count about the radius. They just distance Earth to the satellite. Okay, after that, one more is a radius of the Earth. Okay, now the question give you radius of the Earth, so you must using this one. Okay, I find you many of you, you forget to see this one K. When I mark your last time for exercise, many of you just put 6370 and no more already. So don't forget the K. Suppose is 6370 times 10 power of 3. Okay, then this one later you need to plus. So we call it there's a total distance satellite to Earth. Okay, so this one is an info. Okay, then we continue the question. Let's see what they want. Okay, so now the first one, A, find the value of the ratio T squared and R cubed for the satellite one. So you just apply all the thing in. T squared is how many just now? Then the R cube is how many? Then you give me the answer. So how many here just finish? You, on your mind, you tell me your answer, and also with unit. I want unit. Normally, the first way, what we need to do, we need to find out the R first. Don't straightforward go and do. Then now your R is 3.59 times 10 power of 7. Okay, you need to plus first. Plus the height and also radius. 3, you plus first. After plus, and you get the number here. Then after that, we baru apply, go in the formula. Because your calculator cannot press too many. So this one, you get it 42.27 times 10 power of 6. Then you can apply it.
88 times 10 power of negative.
How many 8?
9.88.
Okay, times 10 power of?
Negative 14.
Unit, I want unit.
what?
T over R. T is what?
S.
S. Got square or not?
Got.
Okay. Then R is?
R is meter
Okay.
-3.
Okay, yeah, correct. Okay. So this one is the answer. Please, the others, don't just wait answer. You finish, you just on your mic. Nobody know who are you. You just on the mic. Okay? So you must try every question. I don't want, I just stop with the A only. Okay, then we continue with the B. Okay, if the Earth distance to the satellite 2. Okay, now they're talking about satellite 2. Distant Earth and satellite mean this one is a H. Okay, remember the H because you need to plus the radius. Okay, now find the orbital period T2 of the Earth for satellite 2. So remember what we learned before for the Kepler third law. Kepler third law, they're talking about T1 square over R1 cube equal T2 square over R2 cube. Okay, this one is a Kepler third law. So just now we find the first one already. We find for the first satellite already. So that means I can apply this answer to this part. Okay, now you are second satellite. Second satellite, that means the R, second R you know already. The radius of the second satellite. There's a H plus the radius of the Earth. Then you need to find is a T2 now. Okay, so you just apply your answer just now 9.88. So make sure this one answer is correct. If this one answer you wrong, then everything also wrong. Okay, so now we go to apply T2 square. We do know how many. Okay, so this one you need to find out first. Then you need to find R2 actually is how many. R2 now is a 3.8 times 10 power of 7 plus 6370 times 10 power of 3 radius of the Earth. After you plus, I get it, there's a 44.37 times 10 power of 6. So you put the number here. Okay, remember your R need to cube. Okay, final I want T2 square. Okay, you get the answer first. Then you go to square root. Then final answer in second. Okay, apply please. Lim Mei Ling. Have you finished?
Not yet.
Si Gajin is in, is it?
Yes, teacher.
So you finish it?
Not yet.
Get it?
Huh?
You finish it? No do or not?
Not yet.
Not yet or no do?
Not yet.
Teacher, is that 2.09 times 10 power of -3 second?
No. First one, you can get the R. After I plus, you get 44.37 times 10 power of 6 first. 拿到吗？44.37乘10 power of 6. So this one you must get first. Remember the R is cube.
Teacher, is that you want the answer of T square one first?
Either one. You give me which one also can.
T is equals to 2.09 times 10 power of -3.
2.09. Why got 2.09? No, others got others answer or not?
Teacher,
Check
answer of
first.
T or not?
No, my answer no like this. The others got other answer or not?
Teacher, 1.19
No. Okay, so t square, anybody can find 8.630 times 10 power of 9. Okay, you take this one. Make sure you check you can take this one t square or not. That means 44.37 times 10 power of 6. You go to cube. After cube, you go to multiply 9.88 times 10 power of negative 14. Ingat tak? T square. Must equal, you don't straightforward. 44.37, that 1 power of 6. You need to cube first. After that, you equal. Don't click all the thing there, final equal.
9.29
9.29 times 10 power of?
4.
Yes. Power of 4, then second. Others, so we just check, is there any problem or not for this one question? Suppose it's all just put in. Calculator must press very careful. Okay, anybody want to ask about the question B? 有人要问吗？
没有。
Okay, then we continue for question 5. Okay, let's see the question 5. Satellite with the mass, okay? They give you the mass of the satellite. Okay, 102 kg. Okay, orbit the Earth. Okay, orbit the Earth. Okay, this one is a height. Okay, height from the surface of the Earth. Okay, after that, height, not count this one. That means we never count for radius. Just height only. Okay, from the, okay, gravitational acceleration for the Earth. Okay, remember this one? Before that, we learned at the surface, there's a 9.81. There's a Earth gravity. Okay, and the radius of the Earth. Okay, they provide the radius of the Earth. 6370 times 10 power of 3. Okay, now, what is a centripetal force? Okay, what meaning for centripetal force? What meaning? Can you find out? Aiyo, if I wait like this, I think until 11 also cannot finish the lesson. Okay, centripetal force is a force, okay, that makes body to follow a circular path with the direction always towards the center of the Earth. Okay, not just Earth. Or any sun also got. Center of curvature. So anything circle, that means the force you just pull, then the direction go there, we call centripetal force. Sun also can, Earth also can. Okay, a force that make a body to follow a circular path with the direction always toward the center of the curvature. Curvature means center, the center point. Okay, I finish to copy. For the student, you have finished to copy, you see the B. What is the orbital radius of the satellite? Okay, they ask you the radius of the satellite now. So the radius of the satellite now is the distance 3,500 kilometer plus the radius of the Earth. So that one is the radius of the satellite. Okay, so we just move to the B. Okay, radius of the satellite. Okay, now your radius is far away. Your satellite is far away from the Earth. So suppose it's R plus H lah. So R is how many? There's 6370 times 10 power of 3. This one's the radius of the Earth. Okay, plus the distance satellite. And remember kilometer. Kilo is power of 3. So the total distance is 9.87 times 10 power of 6 meter. So this one is the orbital radius of the satellite to the Earth. Okay, now C. What is the gravitational acceleration at the position of the satellite? Okay, now you need to refer the question. Question just provide is a 9.81. Then remember 9.81, we're using what formula? Earth surface formula. There's a G, capital M, over R squared. So this one R is what? This one R is a Earth radius when you are on the surface. Okay, here. Okay, normally we get the answer 9.81. Okay, so this one question, we try with the one using the G and with the one using the M. Okay, we're using 9.81 to solve the question. Okay, now this one is a satellite is far away. Remember, satellite is far away, we got another formula to find the gravitational acceleration. So we draw first, we write first, okay, G plan for satellite. Okay, there's a G, M also. Okay, but this one is a R plus H square. Okay, now the question is, they want to find this one is how many? Your gravitational acceleration for the satellite is how many? So from here, I just left you to do it. Okay, final answer is ms negative 2. So I want you just using 9.81. You try the one using the G and the one using the M, because later we can cut one if we make two equations together. Okay, so I just show you the first one. G prime S, that's a satellite, over the G, Earth equal. Okay, so you continue for me. Finally, the answer, I just want this one. Okay, so you can start now. Okay, fine for me, So you write the equation out. Finally, which one we can cut, we just cut it. So you put this whole thing over this whole thing. So I put first G M. Okay, your square don't put in first, plus H square. Okay, you divide the Earth gravitational. Okay, so we put the formula first, don't put the 9.81 first. Okay, now you divide. Okay, when you divide, you want to change back to up. So you need to terbalik the whole equation. So G E is GM over R square, is it? Now R square must put at the top because a chain become multiplied. GM. So which one we can cut? We cut the G and M. Actually, no need to use one. Okay, finally, GS is how many? GS is left R square over R plus H square multiply GE. Okay, understand this equation or not? Okay, not understand faster and ask on the mark, just ask only. I will explain for you. If you just understand, then you can continue to do it. Because GE, we know there's a 9.81. Okay, R is how many? R is just now we count already, is it? The radius plus the satellite, the height. Then this one is a normal, the R. Okay, the R is a normal R, sorry. This one's a normal R. There's a radius of the Earth. Okay, this one R plus H is a radius of the Earth plus the height. Then multiply 9.81. So I want final answer only. GS line actually is how many? MS -2. Okay, you just finish, then you give me the answer. Okay, actually I make you some you are maybe keliru cannot see clear. This one R, suppose I using the small R. This one I need to using small R. I cannot using the big R. Okay, I'm using the small R. Because small r is represent the radius of the Earth. Okay, a chain becomes small r. Okay, small r. Small r. Okay. So small r represent radius of the Earth. H represent distance satellite to the Earth. So the final answer. What's your finish?
40.33 ms -2.
40.33?
Yeah.
No.
Oh.
Try again. You can using the R over the R plus H over first. After that, totally go to square.
Teacher, is that 4.086?
Yeah, that's the answer. 4.086. That's the answer. Okay, so that means because both also square, ma. we can take the R, this one I and this one R cannot cut lah, hello. This one is a plus, cannot cut. So we just take this one R, you press your calculator first, then over this whole thing. This whole thing, we already got the answer here, from here. Okay, 9.87. So that means you take the small r over this whole thing. After over, then you go to square. Totally go to square. Then you multiply 9.81. Then you can get this one answer. 4.086. Oh, okay or not?
Okay.
Yeah.
Mm.
Okay, then we continue for D lah. So like this, the question, they never show anything. They just tell you 9.81. So you need to finish all the things. So that means you must very clear the formula how to use. The whole topic, just play formula only for this topic. There's a new topic for your syllabus. There's a form 4. The whole thing is nothing about the concept lah. You need to put the relationship. No, we just got formula. Okay, so D, what will happen to the gravitational acceleration if the height decreases? What do you think about that? Okay, if the satellite now, I put further, I put shorter, that means the height decreases. I make it shorter. So what do you think about the gravitational acceleration? Bigger or smaller? Okay, when you pull the satellite closer with the Earth, we find it the gravitational must be higher. Okay, so how is she? You see this one, R plus H. R plus H is the distance for the satellite. So when this one becomes shorter, then your G become higher because there's an inversely proportional. So from here we can say gravitational acceleration increases. Okay, what's the reason? The reason is because radius of the orbiter decreases. Okay, so that means the G inversely proportional is 1 over R. Okay, remember this one, before that you plot the graph already. Remember you plot the graph already, this one. Up, after that they slide down. This one means the slide down. And this one is exactly the R. This one slide down. So that means there's an inversely proportional. Okay, number 6, I think your paper got a little bit technician problem. You have me to change, then you redo again. So this one you add the word the. Okay, this one just 1.5 only for the paper. You have me times 10 power of 11 meter. So that means the orbital radius. The sun resolve the sun once a year. Okay, first one they told you a year. T1 with the average orbital radius R1. Determine the mass of the sun. Okay, we know the time, we know the R. We need to find what is the mass of the sun. Then you can recall back in front, they got any formula is count the mass one. Okay, we just got one formula. There's a mass sun equal 4 pi square R cube over G T square. So I want the final answer. Ini, just tell me the answer. Lester, we got so many questions there.
2.01 times 10 to the power of 33.
33? Are you sure 33?
30.
30 kg. Okay, so this one is a mass of the sun. Okay, this one is number 6. Okay, then we go 7. The following diagram that show the Earth, the planet, Mercury, Venus, revolving around the sun. Okay, now we're going to see what they want. Okay, I go to page number 3. Okay, let's see the diagram. Okay, now the diagram, they got Earth. Okay, after that they got Venus, then we got Mercury, then we got Sun. Okay, now the first one they want to find is the orbital period of the Mercury. So that means they want to find, okay, this one we just label lah. There's a T1. Okay, they want to find the T1 for the Mercury. So the first one you need to find out, okay, Mercury, they got provided R1. Okay, then Earth. Okay, Earth, we also know this one is a R. Okay, we label this one as a R2 lah. Okay, now is the orbital period T1 we don't know. Okay, before that, we see the question got provide anything or not. Okay, around the sun, T1. Okay, I miss out one more thing here. Can you help me to write here? This one is orbital period. I think your paper no period. They just write orbital only. So this one is for the Venus. Okay, then this one apostrophe S. Earth, Sun. Okay, so we're going to continue the question. Okay, you see the 7, they say the diagram show the Earth, the planet Mercury and Venus removing around the sun. Okay, so now the first one, removing the sun. So we assume they're removing the sun for the moon, for the Earth. One round is how long? Hello? The Earth, they want to round the sun. Finish to round the sun is how long? Well, the question never provide the time, so we need to assume already. Now the planet Mercury and Venus and so the Earth revolving around the sun. So we just take around the sun because we just know the Earth only. The rest we don't know. So Earth around the sun is how long? One round. How long? T2 is how long? Hey, T2 is how long? Your sun go to your Earth round, one round, you come back. It's how long?
1 year.
Okay, so we just take this a 1 year. So T2 is a 1 year. So this one we don't know lah. Mercury and also the Venus we don't know. So T2 is 1 year. So we can apply the equation because they want to find T1. So Kepler third law. T1 square. R1 cube. T2 square. R2 cube. Okay, T1 is the sun. Okay, T1 is the earth. We take there's a earth. Okay, this one for the earth. Okay, the first one you want to find Mercury, is it? So this one for Mercury. So 1 year, we put 1 only. So we need to see the radius of the earth and also the sun. 1.5 times 10 power of how many? Negative or no negative? 11 only. 11 okay, cube. Okay, this one got square. Square also same. Okay, now T2 square we do know. There's a period for the Mercury, we do know. Okay, but the R we know already. For the Mercury, the R is how many? For the Mercury, the R is a 5.79 times 10 power of 10. Thank you. Okay, now you need to find out what is the T2. The orbital period of the Mercury to round the sun. So your unit, okay, you see, my first one, my time taken, I take year. I never change. Okay? So final answer, your must be take the answer same like the ori, that's a year. Unless you go to change 1 year, you go to change second. So that means later your answer also must be second. If the question like this one, we no need to change one. We just follow. If they're using year, then year lo. Final answer also year. How many year? So you give me the last one, the orbital period of Mercury. Hey, today your form teacher could ask you, ready go to school or not?
God.
Then, how many here is ready? Your teacher catat here, you know, how many, 23, your class so got effort, I want to go to school already. Okay, so the period is how long for Mercury to round? Remember square root lah. Final answer square root. Answer please. What's the answer? How many years?
0.24
Yeah, 0.24 year. Because Mercury is earlier than the Earth, so they must shorter. Okay, then we continue for B. Okay, B now, they want to ask about radius of the Venus. So that means we're still using the Earth lah. The Earth is a T1 square over the 1 cube. Okay, now we go to Venus. Okay, Venus, we know the time already because they said 061 from the years. Okay, from the Earth years. So Earth is 1 year. So that means the orbital period for the Venus is 0.61 years squared. Okay, now it's a R2 cube. So now they want to find is the R2 cube is how many? After you get R2 cube, then you need to, okay, like this. Then you get the answer. Okay, remember, please understand this one as 0.61 Earth years. Means our Earth is 1 year. So you times 0.61. So there's still 0.61. If your year is 3 years, that means you take the 3 years multiply 0.61.
Teacher, answer is that 1.079 times 10 power of 11.
Yeah, 0.79 times 10 power of 11 meter. Okay, so this one is the answer. Okay, we just do the same thing only. Just calculated law, the formula only. Okay, then following is a question 8. Okay, let's see question 8. Speed of the planet that revolve around the sun from the distance is v. Okay, using the calculated law, show that v square is inversely proportional to the r. Okay, they just want you to show out relationship v square and r. So we need to find out what formula they got v square and r, and also using the calculated law. So we take out the calculated law. Calculated law just talking t square. There's directly proportional with the r cube. This one is a calculated law. Okay, so that means if I take out the directly proportional support is one constant number. Okay, before that we prove already. Okay, so from here t. From here the t actually what's the formula? Okay, remember we learned about v. V equal 2 pi r over t. So from here we know lah, v and r of relationship. So we want to create the t here. T equal 2 pi r over v. So that means now calculated law, I want to take out is a t. I don't want got t. Because your final answer, I just want v and r relationship. So from here, I take whole thing, masuk. So become 2 pi r over v square equal k r cube. K is a one constant number. So later we just ignore, never mind, just put first. So now this one I want to solve first. So this one becomes 4 pi square r also square, and v also square. Then equal k r cube. Okay, now v1 alone. So I make the v alone. V square equal 4 pi square r over r cube. Okay, so which one we can cut? The r we can cut lah. R square is it? Okay, r square. So the r we can cut. Finally, the v square equal 4 pi square. Okay, upper no more r already. Down we got one more r. Okay, mana ada k? K sudah makan. Okay is here. K is here. Okay, so this one is the equation. So I continue. I don't want to see so many things mixed together. So I put v square equal. Okay, 4 pi square over k. So we put bracket, then multiply 1 over r. Okay, so now you can see clearly. V and R, what's the relationship? This one is a constant number. Okay, this one is constant number. That means you can say that one is a gradient, you plot your graph. So now V, there's a square directly proportional with 1 over R. So now I can say the relationship V square now inversely proportional with the R. So I can prove. Finally, I just want to prove this formula. Okay, you need to show this all thing. Finally, you want to make out this one is a constant number, then V square equal 1 over R. So this one is the answer. Okay, by using Kepler third law. Okay, because Kepler third law, we don't have any V. Okay, so from here you must create. From here you must to find out which one formula got V, then also got R, then you put it. Okay, this one is a A, no calculation. Just want to show the concept. Okay, no problem on this one. Any question you want to ask? Okay, if no, then we move to B. Okay, now B, they want to find the ratio BP and BQ, the speed. Okay, now we got two satellites. This one is a R, this one is 2R. Okay, so can I say Q, the radius actually is how many? 3R. Okay, then the radius for the P radius is 2R. Okay, because this one is R, then this one 2R, this one inside is R. So it plus together, one is 3R, one is 2R. Okay, around we want to find the ratio VP and VQ. Okay, so from here, we apply just now, we do the relationship, this one. V square directly proportional with 1 over R. So that means this whole thing is a constant number. So can I write V square equal, okay, we put M. M is a constant number. That means gradient. Okay, like this. Okay, so if I move the R here, okay, so gradient VR. Okay, now if I using this one is a case number 1. Okay, for case number 2, the constant number must be the same. If you plot your graph, the gradient must always the same. Okay, V square versus 1 over R. Your gradient is always the same. The gradient is M lah. So if I take the first point, this one is a case number 1. If I take the case number 2, you also get the same gradient. So I can say now the second case, V square, okay, this one is a 1, 1, R2, V2, R2 equal also M. Okay, this one is a second case. So that means I can write my equation now. First case, we take it as a P. P as the first case. Oh, sorry. So I wait the value first. Okay, first case, we take there's a P, there's the first one. My pen. Sorry. Okay, we take this one as a number 1, this as a number 2. So V P R P. Okay, this one goes square equal V Q square R Q. So I can write the equation like this. Okay, why I can write the equation like this? Because both is the same gradient. So we write the equation like this. So now you want to find the ratio VP and VQ. So we just write VP over the VQ. So here should be RQ over the RP. Okay, don't forget this was square. Okay, now if I do want the square, that means the square root must be here. So VP over the VQ, square root RQ, RP. Okay, now we solve the square root RP, RQ. Okay, RQ is how many? Okay, the radius of the Q is how many? There's a 3R. So we just write 3R. Okay, then this one is how many R? This one is a 2R. So R can R, actually we can cut. So what you left? Square root 3 over 2 VP VQ. Okay, so last I'll write here. It's a green color one. A VP ratio with VQ. So that means I can write square root 3 ratio with square root 2. So this one is your answer. So this one is a RQ RP. So this question also no value. You see, they just want to find ratio. So from here, the question A and question B, they got related. We're using the same formula to bring down V and R. Then after that, we find out the relationship P, the speed of the P and speed of the Q. Okay, anybody here want to stop me? Understand?
No.
No, which one you do know? You know
This one
question?
also don't know.
Huh? Everyone also don't know.
Yes.
Okay, question A, you know?
Okay, okay.
Question A, you okay?
Ah,
Question B, don't know.
ah.
Okay, so I redo question B. So I clean first. I open a new page. Okay, so we're going to see question B. Okay, just now, the answer we find it is T square directly proportional with 1 over R. This one is just now we find it. Then after that, I say, if I want to ignore the lambda, actually it's a T square equal gradient 1 over R. This one gradient means when you plot the graph T square versus 1 over R, one straight line. That means you find the point. Okay, you find the gradient. Okay, example, this one is T1. This one is 1 over R1. Then you find the answer should be, the gradient is M. So if I set another point, T2, and you draw the line, you come here, so it's 1 over R2. You find the answer also is gradient, is it? The gradient at the point, the whole line, the point is the same one. Okay, I don't care you T1 or T2 lah. When you're using T1, you must over 1 over R1. If you're using T2, you must over 1 over R2. So that means you find the answer is always just gradient only. So that means every point on the line actually is a constant number. So that means now I can write the equation T1 square, okay, equal M over R1. Then T2 square also is a M over 1 over R2. So actually the M is the same thing. So that means now if I bring the R1 to come here, T1 square R1 equal to M. Then this one, T2 square R2 also equal M. Is it? So that's why I can put these two together already lah. T1 square R1 actually is a T2 square R2. Understand? For this one.
Yes.
Yes, So now I want to represent 1 and 2 already. So P take as a 1. Q take as a 2. Yeah. So now T1, that means TP lah. TP square. Okay. Now this one is R1, is it? Okay, this one just R only, you never plus this one, you must plus this all. So this one become 2R already. So I must put 2R. Okay. Then equal, then T2, T2 is a Q lah. Q square. Okay, R2 is how many? R2 is 3R already. Okay, so now they want to find VP, VQ. VP, VQ. So from here, we go and see, is it I do the wrong thing? Okay, so nobody want to tell me I do the wrong thing. So yes. I'm starting sudah salah lah, hello. V lah. T some more. V. All is a V, not T. Because just now the question we prove is a V square 1 over R. So this all is a V, yeah? V. So just change become the V. Okay, V and R. So I write here VP square 2R equal VQ square 3R. Okay, no T, it's V. Okay, now we continue with the VP over VQ. Okay, this one got square, this one also got square, so total square lah. Equal, okay, VQ because you pull down already, so this one 2R must go another side. So 3R over 2R. Okay, until here. Okay or not? Hello? You just change become T. Yes, so I continue here. Okay, now, because you want to find ratio VP and VQ, no square one. So the square, you must hilang the square. So now, VP, okay, versus VQ equal square root 3R over 2R. Okay, this meaning is what I know. VP ratio VQ means VP over VQ. This one, the meaning is the same. This one and this one, the meaning should be the same. Okay, so from here, if I put back this part, VP ratio VQ, actually is what? The R we cut first. Square root 3 ratio square root 2. Okay, you must know this one. 这个 VP ratio VQ 的意思其实就是 VP 除 VQ 的意思。如果我讲你 final answer 是这个嘛 that means 这个 ratio 这个其实它的意思就是 R what? The first one is R for the 3R is this one. Okay, RQ ratio RP. 其实它的意思就是这样。Okay, 倒反VP ratio VQ, then this one is RQ ratio RP. Because you divide, when you want to move up, you need to terbalik. So this one is a final. Okay, understand?
Yes.
Yes, so we need to continue the following also like this one. Now it's a T period. Okay, then you see the question 2. Now they call you to calculate the ratio TP and TQ from the Kepler third law. So we need to using Kepler third law lah. So Kepler third law is what? T1 square R1 cube equal T2 square R2 cube. This one is a Kepler. Okay, so we still again take the 1 is a P, Q is a 2. So we just write TP square. Okay, then I want the TQ go down. So the TQ, this one is a TQ, become, wait, I let you to see clear first, don't change first. So we just write RP cube. Okay, then this one is a TQ square. R cube. Okay, like this. Okay, so now we need to find out the answer. Okay, TP. So I move the TQ come down first. I move this one come down. I cross. I multiply with the cross because I want to find the ratio. Remember, this one meaning is what? This one meaning is TP over TQ. So now I make TP square over the TQ square. So equal this one up already. So this one become RP cube. This one is a R cube. Okay, so you see P over Q. Then this one should be the body. Then we come to here. This one is a Q square. Come down. Then this one go there. So Q is up. If you this one come down here, then this one must be up here. So actually these two formula is the same formula one. Depend for yours which one you want to use lah. If you're using P, both also P. If you want using both also P, both also T. Either one. Okay, so now I create already this formula. Okay, this formula is a ratio already. So from here, I want to solve is a R. Okay, so RP cube. RP cube actually is how many? There's 2 over 3, is it? Just now we find already. R is 2R. And cube. Then RQ is 3R. Okay. Then TP over TQ. Okay, square I want to take out. Then I go to square root. The whole thing I go to square root. Because the square I want to take out. So until here, understand or not? Not yet finished. We still got R, we need to cut. Okay, TP over TQ. Okay, R we go to cut first. So after you cut, that means this one is a cube. Then this one is a 3 cube. Okay, after that, square root. Okay, then we continue. Okay, 2 cube actually is how many? 8, is it? And 3 cube is how many? 27. So it's a TP over T cube. Okay, now we write like this. Square root 8. Root 27. So this one is the ratio. There's some they still can write shorter some more. 2 square root 2. 3 square root 3. It's the same answer. Okay, anybody want to ask? Number 2, Kepler law. how to create this one equation. Final answer for ratio TP and TQ. So understand? Hello, understand or not? If understand, then we can move already. If not understand, then you just on your mind and you say you not understand. Then we continue for explanation. Okay, respond please.
Okay.
Okay.
Okay, then we go number 9. Okay, you see number 9. Okay, the following diagram will show two satellites again. One is K. Okay, K and L. Distance is 3R and 4R respectively from the center of the Earth. Okay, center of the Earth. So understand, center of the Earth. So this one is 3R. This one is 4R. Okay, so now, if the orbital period of K, okay, they give you the time. What is the orbital period of the L? Well, L is a T2 lah. So we know the R already. So we're using Kepler third law, T1 square over R1 cube, T2 square, R2 cube. So T1 we just apply. T1 is 7.3 square. Okay, R1 is K, is it? So we take 3R cube equal T2 don't know. Okay, then the L is a 4R cube. Okay, find for me what is the period of the L. Then if they're using hour, then be hour, because you never change. How many hours? Finally, how many hours? Tuition. Esther. What are you all doing? Esther, Eric. Iru, finish?
No.
No. Jia Wei, Tan Jia Wei. Hey, Jess, Tan, you finish or not? Give me answer lah.
Uh, 11.24 ah.
Yes. Unit. Unit is what?
Hour.
Okay, we just follow hours. Okay, finish like this only. Just apply, then put in, then take out. That's all. Okay, then we go to B. Okay, how much does the height of the L require to increase? Okay, now that means the L here, they want to increase some more. They don't want to increase how many lah, H lah. Okay, they want you to find out. So now they want to make it increase order for its orbital period increase to 15 hours. Okay, so just now you find 11.24, is it? Now they say they want 15 hours. They ask you how many they want to move further some more. So from here, we're still using the same thing, the same formula also. Kepler, there's okay, we take the 7.3 for the K. Okay, after that, 3R also for the K. But now, this part, we cannot using 4R already. We must using 4R plus H. Okay, because we do know the H how many. So that's why the question wanted to find out. So we just apply. It's 7.3 square. Then 3R still the same. 3R. Whole thing go to Q, not R only, 3 also need to Q, Okay, now T2, we know already, there's a 15 square. Okay, now at the bottom now is 4R plus H cube. So what you need to do, you find out the 4R plus H actually is how many first. After that, you baru go to minus. That means your final answer got R lah. No, we do know the R. The question never say the R is how many. Okay, final answer H is how many R. Then the unit meter. Long time never call a hole.
Don't know how to calculate the H. Just get the 4R plus H cube.
Okay, wait, you just sorry, I think I missed out something, is it? You do this one already. Okay, yeah, here. Okay, to tell you this one. Okay, the cube is here. Okay. Okay, what's your answer for 4r plus h cubed?
114.00.
Okay, 114.0. Okay, got times stack anything or not? No.
No.
Okay, so from here, we go cube lah. 4r plus h, is it? Go to cube lah. Okay.
Okay.
Then I want the answer is h. Oh, what's the answer?
0.85.
Yeah, 0.5. Remember, we still got r. R cannot ignore unless the question give you r is how many. So the answer is 0.85 r diameter. Okay, so this one, that means now if you want to get 15 hours, that means your satellite need to move some more 0.8 r. Okay, 85 r, then away. Okay, Aho, you okay or not?
Okay.
Yeah. So this one is the B. Okay, we left two more. Okay, two more. Then we go question 10. I think question 10 is no problem. You can straightforward to apply. Okay, you see the question, then you can do it. Question number 10. Okay, question number 10. Earth mass and also the Uranus. Okay, they give you the mass and radius for each other. Find the magnitude of the gravitational force. Gravitational force is the first one what we learn. Okay, the formula is F equal G capital M small m over R squared. Okay, this all is surface. So surface, we no need to plus anything lah. So I want the answer for number 1, Earth 1. So Earth and also the mass of the object is a 50 kilogram. Okay, you give me the answer for first. Okay, Earth and object. Number 2, mass and object. And number 3 is a Uranus if object. Okay, I want the first answer. Get it? Just on mic, tell me how many Newton.
For 88.81.
For
88.81.
88.81. Then the unit is?
Newton.
Okay. Next.
184.74 Newton.
184.
4.74
Yes.
Newton.
Okay. Last.
464.5
0.5.
Newton. Yeah.
Okay. So we finish. This one is our answer for the force. Okay, just apply only. This one is the easier one. The first one we learned. Okay, then we continue for B. Okay, now diagram show the rocket. Okay, a rocket at the rocket launch site. Okay, rocket is on the surface. Okay, on the surface. Okay, so now you can see what they want. If the rocket at the launch site experience the gravitational force, okay, they got this one force. What is the mass of the rocket? Okay, again, the same thing. G, capital M is for the Earth, small m is for the rocket, then R square. Okay, then R square we refer here lah. What is the radius of the Earth? Okay, so we need to find is M. For rocket is how many kg? Okay, how many kg for your rocket? This one mass is how many? This one radius is 6.4 times 10 power of 6. Then you need to square. Hào 好了吗？好了吗？给我答案。谁做完了？
5.11 times 10 to the power of 4 kg.
Yeah. Okay. So this one answer. Okay, so number 2, we just go and underline lah. If the rocket is 100 kilometer above the Earth's surface, what's the chain for gravitational force? Okay, what do you think about that? How about the F? Okay, we see the relationship. So now they say 100 means now is G. This all is a constant. Okay, now that means your R. Okay, need to plus 100 times 10 power of 3 some more. Then you need to square. So this one number become bigger. What do you think about the force? Force sure become lower, inversely proportional. So that means your answer is decreases. Okay, then we go 11. Satellite with the mass M. Okay, this one M. Okay, the height is a H. Height only, never plus the R. Okay, now the surface Earth with the mass is capital M. Okay, R is the radius of the Earth and H is the distance between the satellite and surface of the Earth. Okay, first one, we answer express the radius of the satellite in terms of R and H. Now, can you tell me the radius of the satellite is how many? I just want the answer in R and H. Then should be R equal?
R plus H.
Yeah, R plus H. So this one is the radius of the satellite. Okay, now they want you to show show explanation for the gravitational acceleration, this one formula, from the satellite at the height h. Okay, how to get this formula? How many here still remember? Okay, before that, we ignore h first. How to get this formula? G m r squared. How to get this formula? This formula is come from where? Gravitational acceleration. Okay, before that, we learn about one of the formula is a F equal ma. Then we're talking about weight, your gravity. So we change already, become mg. So we take this one equal to the, this one is the gravity. This one is for the gravitational law. Okay, there's a equal G, capital M, small m, over r squared. So we put together mg equal G, capital M, over r squared. So we put like this. So that's why finally we get the equation for the G. So actually, which one is no use here? Actually, it's a mass of the small object. And this one is a mass for the Earth or either Sun. So normally it's the Earth lah, because the satellite is surrounding. So from here, we can create now G equal capital G, capital M, r squared. This one is normal when the satellite on the surface. This one is normal. So you want to get this one formula, so you need to explain. Now the satellite is satellite distance is equal r plus h. So that means conclusion, I can write the equation now. G for the acceleration due to gravity now is a gm over the r plus h squared. Okay, so this one is what I need to know. The radius of the satellite now is a r plus h. So you need to show this one first lah. Show this one equation, how you get the normal first. After that, you create. So this one r plus h actually is the whole radius, the satellite and also the radius of the Earth. Okay, so no calculation, just want to expression the equation only. Okay, finish, huh? Okay, then we go to the next one. The next one is a C. This one is a C. Okay, C. Now the satellite orbiting around the Earth. Okay, we draw. Okay, satellite orbiting. Okay, the height of this one is 500 kilometer. What is the value of the gravitational acceleration at the satellite? Okay, now radius is here. Okay, so the radius, the question give you already. The radius of the Earth is 6.4 times 10 power of 6. Okay, then finish. The question want to find is a G prime. That means now is a satellite up. So we write out again GM. There's a R plus H. So we just apply G is how many, M is how many, M is the mass of the Earth. Then I want you to do is this part. You find for me R plus H actually is how many? This one got square. Actually, how many first? Okay, after that you bring the answer, come here, then square. So I want final answer in MS -2. So 12. Okay, you can apply. Give me the answer.
8.41.
8.41. Got any power or not?
No.
No. Okay, so this one is the answer. 8.41. So that means normal is 9.81 for the Earth because you further already. So that means your gravitational acceleration become less. Okay, now we continue with the D. D also is the same thing. They just say surface. Okay, now at the surface. So at the surface, we're using all the things they provided lah. Okay, they give you the Earth now like this. Just now the Earth is a different. That's a 6.4. We follow question. If you're using 6.37, then we're using 6.37. So now gravitational acceleration on the surface. Still the same thing over r squared. So now your r straightforward, you take the total radius of the Earth, no need to plus h. Then you'll find what is the gravitational acceleration on the surface.
Nine point 81.
Yeah, 9.81 is exactly our gravity. Okay, so the following not 12, following is E because they refer the question. Okay, refer the answer C and D. What is the factor to determine the value of gravitational acceleration? Actually, what's the factor to affect the answer? Why one got 8.41, another one 9.81? What is the big factor? What's the factor to make the two answer different?
Radius.
Radius.
Distance.
Distance. We cannot say radius. Radius fixed already. Radius for what? Radius for the Earth fixed. Or you say radius for the satellite orbiter. Okay, then we can accept. Or you can say the height of the object. Because the height of the object you further, then you get the answer also different. So we must write the full sentence. Okay, the question here, they never say satellite or what. We just take there's an object lah. The object is where? Okay, the height of the object. There's a big factor here. Okay, now, can you give me the relationship between the factor that you mentioned just now and gravitational acceleration? So if I say height lah, height of the object, can you give me the relationship? So when?
When the distance increases.
Okay, when the distance, or say when the height of the object, okay, increase. Okay, if I say increases, okay, what do you think about the gravitational acceleration? The gravitational acceleration?
Decrease.
Okay, decreases. Okay, so this one is 3.2. Very hard, is it? No.
Hard.
Hard. I don't want to ask the guy lah. The guy always answer lah. I just ask the girl lah. Girl, hard or not this topic?
Yes.
Yes, very hard, is it? So what you need to do, practice. Do the practice. Not just see the question. Oh, I know already. You must use your head to count, to write, to press your calculator. When you press more, then you more often already, then you know how to press. You suddenly go to press, you sure don't know one. Okay, so this one is an exercise I can give you. So this one I also record already, later I will upload. So thank you for your listening today. Okay, almost 2 hours. Okay, so we finished 3.2. We still got one more is 3.3. Okay, they almost got formula also. So that means the whole topic is a formula. Okay, so understand today? The lesson understand or not? Hello, understand or not?
Yes.
Yes, So thank you, class. So you can leave now.
Thank you,
Thank
teacher.
you, teacher.
Okay. Bye.
Thank you,
Bye.
teacher.
Okay, bye.